So this is a supplementary lesson to supplement lesson 57A in your textbook, phase shifts in sinusoids. I'm going to go through a discussion of the phase shift in the same way the book does. I'm going to do it in a little different approach than the book does. So hopefully will help you maybe understand it a little better if the book explanation left you wanting. Okay, so right up here what I have, if you can see the colors, it looks like they come out okay on the video. The yellow curve here is our typical sine curve with a magnitude of 1. Okay, our orange curve is our typical cosine curve with a magnitude of 1. And then the book mentions in that section shifting starting with the sine curve, and this is the red. So our shifted curve will be in the red. Okay, this red one kind of here in the middle. Now you notice right off, the sine curve and the cosine curve have the same exact shape. Okay, so if we were to shift the sine curve or cosine curve over 90 degrees either way, they would directly overlap each other. They would be the exact same curve. So this is a thing to remember when shifting the cosine sine curves, and a shifted curve like this red curve, we can express it as a shifted sine curve or a shifted cosine curve because they're both the same shape. It's just, you know, how much are we moving it and which trigonomic graphing expression are we going to use as our base? Are we going to use the original cosine curve or the original sine curve? We can use either, doesn't matter. Now the book will tell you to express a shifted curve basically in the sine function or cosine function. And by the way, they can both also be expressed as the negative. A shifted curve can be expressed as a shifted negative cosine or a negative sine, because those curves have the exact same shape. If they're they start at different points along our what would normally be our x coordinate system or our what we have graphed for angles. Okay, so just real simple, more of a simple explanation, I think, than the book. In the case of the sine curve, we've known from previous studies to shift a curve. Okay, our sine curve, we're going to shift 45 degrees to the left. Okay, and we can do that if x is in our function by adding x. So if we wanted to shift our graph 2 units to the left in the x direction, okay, we would put the x plus 2 in place of x in our function, okay, and then simplify that expression. It's the same drill here. We're shifting it to the left 45 degrees, so we put x plus 45 degrees in place of x. Of course, in the sine function, we don't have x, we have theta. So instead of x plus 45, we put theta plus 45. Okay, that becomes our expression for that shifted curve. So sine of theta plus 45 would now represent that red curve here in the middle, shifted to the left, the sine function shifted to the left 45 degrees. Now, the book says the phase angle, okay, just keep this straight, the phase angle is the amount we've shifted. So however much we've shifted the function, 45 degrees to the left, okay, that is also the phase angle. But the expression inside of the function is going to be theta plus 45, just like in the case up here with x. And it's the same drill with the cosine function, okay? We're going to shift the cosine function 45 degrees to the right. It tops out here normally, okay? We're going to top it out here instead, 45 degrees to the right, okay? So we replace, instead of x minus 45, we're going to replace it with theta minus 45. That will be the expression of our shifted cosine function 45 degrees to the right. Okay, and again, notice the phase angle indicates which way is the curve actually shifting on the graph, right or left. Okay, it's the same as the amount that it moves, the phase angle. Now notice, when we move the sine function 45 degrees to the left, or we move the cosine function 45 degrees to the right, they both will overlap along this red curve. Okay, so we can express that red curve either as a shifted sine function or a shifted cosine function. It doesn't matter. They'll both represent that same red curve. The book will tell you which function to express it in going forward. So I hope that helps with this lesson. Shoot an email or a text message with any questions on your advanced math homework. See you later.